This is R.D. Sharma solution class 12. We are taking exercise 19.27 of chapter 19, Indefinite Integrals. Now in this question, 1 by x cube sine log x. So there are three functions here. First is 1 by x cube, then we have a sine function, and then the log. So we have algebraic, logarithmic and sine function, that is trigonometric function. So we'll take this log x which is inside the sine and we'll place log x equals to t. You already know that base is e, so in the previous discussion also I have explained this is equal to e raised t equals to x. So this x equals to e raised t. So we are going to use this one and this one in the later part, and let's differentiate both the sides. So dx by dt will be equal to e raised t because we are differentiating with respect to t. So we are doing d by dt of e raised t, that will come as e raised t only. So dx will be e raised t dt. So when we are taking log x as something, says t, then we have to talk about dx also. And dx also has come as e raised t dt. So this integration will be formed like this. 1 by x cube. Now x is e raised t. So x cube will be e raised 3t. So e to the power 3t it is. Now what is the benefit? You might be asking why t equals to log x you have put in. You'll see 1 by e raised 3t sine. Now log x you can write just t. And in place of dx we are going to write e raised t dt. So I'm replacing this 3 here now. E raised t dt. So e raised t is there. E raised 3t is in the denominator. When it goes up, e raised negative 3t and e raised t, the power will get added. T minus 3t is negative 2t. So this whole will be e raised negative 2t. This integration will be e raised negative 2t. This and this one has combined and e raised negative 2. And of course sin t is already there. Now we'll integrate this. Now we can apply the ILATE. Integral, log, algebra, trigonometric and exponential. Which one comes first will be the first function. So sine function will get the first position and e raised negative 2t, which is the exponential function, will be the second function. So integration of u into v dx, this is the formula I am using, and I am quite aware that you are aware of this solution or the expansion of this integration u dot v. So sin t comes outside, e raised negative 2t inside, that minus differentiation of sin t, and then integration of e raised negative 2t dt, and then again an integration will be done. So this is sin t, e raised negative 2t will be e raised negative 2t only. Then we have to differentiate negative 2t, negative 2 will come and that has to be kept in the denominator. So negative 2 will come in the denominator, minus integration. Now e raised negative 2t by 2, negative 2 will come from here and sin t will be cos t, and again integration will be done. So we'll do what negative 2 will bring in front. Why? Because we just need cos t e raised negative 2t inside. So when you take this negative 2 inside, this plus half will come outside. So let's call this initial one as I, and let's call this one e raised negative 2t cos t as I1. So we'll do it separately. This e raised negative 2t cos t, we are calling it as I1. So there will be a reincarnation. What I am saying is this will come again. You will see e raised negative 2t sin t will again come, or e raised negative 2t cos t will again come. That is going to be in the future just now. So let's call it as some I1 or some other I2, and I am integrating it the way we have just completed the previous one. So I am applying u dot v here. So same thing here. So this will give you, so I am cos t, and this e raised negative 2t will be e raised negative 2t by 2, e raised negative 2t by 2 here. Cos t will be negative sin t. So sin t here, negative goes outside, it will be plus. So negative, negative, plus, and you don't have to take negative outside or make it as plus because negative, negative can be cancelled here only. So you can just write e raised negative 2t by cos t divided by negative 2, and half I am bringing outside, the sign will not be changed. E raised negative 2t sin t. Now you tell me, what is this? This is what? This is the initial one from where we started. So this is actually the fourth equation, if you call it 4. So we'll just write I here. Now I am changing now because this is I1 actually. So I am going to place I1 in place of this expression. So I will be equal to, this is e negative 2t sine t divided by minus 2 plus half, and in place of cos t e raised negative 2t, I am going to write everything which we got for I1. So this e raised negative 2t cos t by minus 2 minus half, and here only you have to write I. Now you can take, first you have to multiply a half inside, then we'll deal with the other thing. So e raised negative 2t sine t negative 2t, this doesn't change. Here we have half and negative 2 will be negative 1 by 4, e negative 2t cos t. Now when we multiply half with negative half, it will be negative 1 by 4, and this will be I. Negative 1 by 4 I will be taken on the left. So we'll combine this I and 1 by 4 I, and this will give you 5 by 4 I. 1 plus 1 by 4 is 5 by 4. So 5 by 4 I will be equal to, now we can take something common here. E raised negative 2t is already outside, so you can take common. Now you have minus minus, both terms are negative, so you can take a negative outside. You can take a 4 in the denominator. When you take this, so this everything will be plus inside now, because negative is already taken. So e raised negative 2t divided by 4. Since 2 is in the denominator, you have to multiply it by 2. So the first term will be multiplied by 2. So 2 sine t will be there. And this will be, 4 is already taken. E raised 2t is negative 2t is already taken. So you have cos t inside. So there is a little space left for us, but I will cancel this 4 here. Bring this 5 downstairs on the right hand side. So e raised negative 2. So what is e raised negative 2t? See, e raised t was what? If you remember, e raised t was, this is e raised negative 2t. E raised t was what? X. And if you just take the power negative 2 will come here also. It will be x to the power minus 2. So 1 by x square it is. So in place of e raised negative 2t, you can write just 1 by x square. This is 2 sine. What is t here? Log x. I told you I'll use that thing. So log x here. Plus cos. Inside this we'll use log x. Cos log x. And now I will finish it off with the constant of integration. So this is your final result. Now let's see that this is how we are going to solve it. This is the reference for you. You can follow this reference. There are certain intricacies which I discussed with you, but the way you write is something like this. E raised to x, cos square x and dx. Now sin square x you already know. We have already done that question. You know that 2 sin square x is 1 minus cos 2x. 2 cos square x is 1 plus cos 2x. So cos square x will be equal to 1 plus cos 2x divided by 2. So in place of cos square x, we'll replace this. So integration of e raised to x, this is half. So I'm taking this half outside. So e raised to x and 1 plus cos 2x. So we can deal this half later or maybe here also. But we'll see. E raised to x, let's multiply this inside. So first term will be e raised to x only. And the second term e raised to x dx, and the second term will be e raised to x into cos 2x. There are two different terms we got. So e raised to x integration will be e raised to x only. Then 2x will be differentiated, 2 will come, that will go in downstairs. So this half you can multiply here. So let's multiply half here itself. So e raised to x by 4 plus 1 by 2 e raised to x cos 2x dx. Now let's call it as I1. So we'll do this I1 separately and then we will replace it. So I1 becomes e raised to x cos 2x dx. So those who have already done this, they can just go to the next one, because this is e raised to x cos 2x e raised to x sin x we have already done. So the integration will be integration of u dot v. I'm taking cos 2x as the first function. So this is the u dot v integration. So this will come. This is how we elaborate or apply the formula. So cos 2x e raised to x will be e raised to x divided by 2 minus d by dx of cos 2x. Cos is minus. So minus I'm bringing outside. So sin 2x, 2 will also come. E raised to x by 2 this will be. This is dx. So 2 you can cancel. Now sin 2x into e raised to x, I'm calling it as I2. So if you see the solution or reference, you will not see these I1, I2, all these etc. But since I want to explain you, I am taking this separately. So I2 is integration of e raised to x and sine 2x. So it's a altogether different integration. So sine 2x will come first. Again, integration of uv. U I am taking as sine 2x, v I am taking as e raised to x, and you know how this go about. So we have e raised, this is how we open it up. So this will be sine 2x, e raised to x will be e raised to x by 2, and then we have minus sine 2x is cos 2x, and 2 will come in front because we are differentiating. This is e raised to x by 2 dx. 2 gets cancelled. Now what do you see here? This is actually I1. I told you e raised to x cos 2x dx. I am assuming it to be I1, and it is actually I1 only which is coming again. So e raised to x by 2 sine 2x minus I1 is actually equal to I2. Now this I2 has to go there. I'm just trying to divide and conquer. So I'm bringing this I2 here, and this whole has to be placed in place of I1. So let's write I1 first. I1 will be equal to cos 2x, e raised to x by 2, and cos 2x you can write cos 2x. And in place of all of this, you will write this I2, which is e raised to x by 2 sine 2x minus I1. And this I1 you can bring on the left, so it will be twice of I1. So you can just take this here, cancel this I1, 2 will be coming on the right downstairs. Now put this I1 in the original one. So e raised to x by 4 plus, now you have to multiply this with half, because this is I1 but half is already there. So 1 by 2 into 1 by 2 is 1 by 4. So e raised to x by 2 cos 2x plus e raised to x by 2 sine 2x. Now e raised to x by 4 will remain like that. But in the second part you can just do something, like you can take something common. So e raised to x by 4 it is plus. Now you can take e raised to x outside if you want. But first multiply, let's multiply first. So when you multiply this 4 in the denominator, it is 4 to the 8, 4 to the 8. So 8 comes in the denominator of both the terms. So this 8 you see, plus constant of integration. Now you can do one more simple thing, which is not required actually, but e raised to x by 4 plus 8. Now you can take e raised to x common and 8 common, because it is common in both the terms. So e raised to x divided by 8, it will give you sine 2x plus cos 2x plus constant of integration. This is your I. Okay, this is your final answer. So this is the way you are going to go about it. And there are I1, I2, I took, but I hope you will be able to do this. E raised negative 2x sine x. So e raised 2x sine x, e raised 2x cos x, e raised negative 2x sine 2x, e raised negative 2x cos x, cos 2x. All these sort of questions we have done. And you already know this, how to do this. So let me show you the reference. If you have any problem, just let me know in the comments, and I'm going to solve this again. But if you're following me, then you already know how this question is done. Now you have x square, e raised x cube, and cos x cube. So there are three different terms there, but there is something which is common here, which is x cube, because differentiation of x cube can give you x square also. Now let's take this. Okay, let's take x cube as t. So dt by dx equals to 3x square. So dt will be equal to 3x square, dt by 3 you can bring in x square dx. So x square dx we got. So this I will be equal to, in place of x square dx, just write dt. 1 by 3 can be brought out. Ex cube, so e raised t. Cos x cube is cos t. Now do you see? E raised x, cos x, e raised x, sin x was the first thing I told you in the beginning of this discussion. So there is just a revision of e raised x, cos x, which we are going to apply here. So we'll apply the isolate here. So this is 1 by 3. We'll talk about this 1 by 3 later. But e raised t cos t is the first function, and e raised t is the second function. So I'm applying this u dot v integration, and you know already how to do that. So we have this expansion of that formula. Cos t, then e raised t minus d by dx of cos t is negative sin t, so I have brought negative outside, and then e raised t dt. Now we are doing it separately because this is going to come again. You already know that. So we call it as I1. In sin t, e raised t, I am applying this uv integration again. So you all are already aware of that. So let's do this. I1 and is having two functions. First function we are taking sin t. Second function we are taking e raised t. So this application of this formula we are applying. d by dt of sine t, again integration of e raised t dt, this whole. So we have e raised t sine t minus d by dt of sine t is cos t, e raised t is e raised t only dt. So you don't have to integrate this because this is the original one. If you remember, if you make 3i, then it is actually equal to integration of e raised t cos t only. So e raised t sine t minus, so e raised t cos t is simply 3i. So now I'm writing 3i here and I is on the left. Now let's transfer this in I. So this I will be equal to 1 by 3 was already there, cos t e raised t. So let's write it like that only, cos t e raised t. In place of this I am writing I1 now, e raised t sine t minus 3i. So we need to multiply this 3 inside first. So this I will be equal to, it will be 1 by 3 e raised t I am taking outside, and I'll just take 1 by 3 and e raised t outside. So it's better because cos t plus sin t will remain inside. When we multiply 1 by 3 with 3i, it will be I only. Now this I goes on the left. I minus I on the right will become 2i, I plus I. It will be e raised t by 3 cos t plus sin t. Now just take this t equals to x cube. So bring this 2 in the denominator. I will be equal to e raised t will be x cube, and then 3 2s are 6. Then we have cos x cube because I am replacing t by x cube now, plus sin x cube plus a constant of integration. That is your final answer. So this is how it will be done. It's a very simple question because this kind of question we have done previously also, but you need to write it in the way I am presenting. So this is all about this exercise. Thank you so much. Have a good one.